My background is most of you, if not all of you know, cognitive computing is a very broad area encompassing pretty much every discipline we have, neuroscience, computer science, mathematics, physics, biology, and of course, very few of us have expertise in all of those. My expertise is largely around software engineering, and you might ask, well, why does that make me sort of a speaker in this topic? And hopefully you'll see from the conversation that one of the things I actively do, I'm part of IBM Research, and one of the things that I actively do is I work with a lot of businesses, a lot of C-suite executives, and a lot of the purpose of my interaction with them is to help them understand the art of what's possible with technology, but also to look ahead in terms of where technology can actually make a profound difference. So with that, let's get started. I thought it would be interesting to have a little bit of a history lesson before we talk about cognitive computing. Now, this is a point of view, and our point of view, and it's a point of view that we as a company, IBM, have been putting forward in the marketplace, but I think it's rather interesting and insightful. I know that's a self-serving statement, but when you think about our computer field for a moment, before we had the transistor-based, silicon-based technologies that we use today, we had mechanical devices. We had this sort of tabulating era. So the message here is multifaceted. One message is that we do believe that there is this concept of computing eras, and we do believe they last anywhere from 50, 60 years. And of course, we've long left the tabulating system era, the era where we had machines that did tabulations and basically arithmetic. And that brings us to what we consider an era that we find ourselves in right now, which is this programmable era. And the programmable era, sort of as the name suggests, whether we like the name or not is irrelevant. The name is simply suggesting that we program computers today. That's what we do today. We bring data to computers, and we do that in large numbers. But the other interesting thing is when you look at this era, you'll notice that we highlight 4 distinct evolutions within that era. So the first evolution in that era, of course, is the inventions of silicon-based computers, where we did all sorts of great things and built all sorts of great applications that we use today, whether they're an airline reservation system, an ATM application, medical equipment, real-time air traffic control systems. But we rapidly saw the arrival of smaller computers, the PC, and of course, we coined that the client-server era. And then, of course, we went further and we saw the arrival of the internet. What's my point? The message is that if you think about what happened with each of these 3 evolutions, we saw new business models emerge, we saw new companies emerge, we saw new applications emerge, and we saw some pretty significant economic changes, and I would also argue that we saw an improvement in the quality of life. We fundamentally believe that there's a 4th era that is upon us right now. It's sort of silently touching us, and some of us are very clear that this era has hit us, and some of us are a little bit blind. But this next era we call the confluence of many different technologies. It's the confluence of mobility. It's the confluence of social mobility, analytics, and cloud all coming together to create an actual new value proposition. But the reason I pointed out is multifaceted again, but one of the reasons is that we believe it's an inflection point of this next era of computing. And this next era of computing is what we call cognitive. Now again, maybe you dislike that name. I know that I've seen names in the marketplace called ambient computing, but the point is that when you think about ambient computing, which sort of says that computing is everywhere, it's among us, it lives with us, or cognitive computing, which really says that computers begin to take on human-like characteristics, the point is that we do believe that there's some fundamental, which we'll get into in a moment here, there's some fundamental differences in cognitive computing. But this is not simply theory. It's the next message. This inflection point that I mentioned, I think, reflects the fact that we see within the businesses and the world that we live in, we see a tremendous push for doing more with technology, being able to do, and we see that from a variety of companies. Many of those companies are in the room today, whether I don't know who all is here, but I know SAP is here and Intel is here, and and a bunch of other companies, and all of you are doing work in this space. So just a quick definition of how we've defined cognitive computing, but it truly is having technology, having systems that take on human-like characteristics. Now, I know many of you, if not all of you, are familiar with the Watson technology that we introduced in the Jeopardy game, and I know that some of you would debate whether that's cognitive computing at all, but I think what we would agree on is it certainly did bring to our attention the ability of computers to engage like people with natural language processing. It certainly put some new life into artificial intelligence and our ability to actually take a rather broad domain like Jeopardy and to actually have a computer compete with the two best players in the world. And of course, that's an interesting problem, but it certainly is not life-changing. So what we've seen with Watson in terms of what we've been doing with it for the last 2 years, and again, just so you have a little bit better understanding of who I am. So my biggest role in Watson after we won the game in Jeopardy was to sort of find work for Watson. That's sort of what I do, is to look at how we apply our technology in various aspects of the world and in business. But in the case of Watson, we spent most of our time with Watson with the Cleveland Institute in Cleveland. We've spent some time here in California, in Southern California, with WellPoint as well. But the interesting thing that we've done, we've worked with some of the best oncologists in the world. And what's been remarkable, what they have told us, because Watson has gone to medical school, Watson, although we have some reasons not to, it could pass a medical test today. But when you look at the work done by some of the top doctors, in this case an oncologist in the world, what she told us is that when she started engaging with this technology, and we actually created something called Watson Paths. And so think about the technology this way. Think about sitting in a room, you're a doctor, and you're trying to make sense of a tremendous amount of data that is in front of you. Some of that data is visual, so you have to be able to visually interpret it, and a lot of it is research data. And you're a pretty talented doctor yourself, so you're the top of your profession. But at the same time, you've got a tremendous patient workload. Wouldn't it be nice? Wouldn't it be advantageous to have a piece of technology that was sitting in the room with you, and you could simply ask it questions. You can say, well, what do you think about this? And not only could you get back an answer, but you could get back an answer that gave you sort of a probabilistic evidence of its correctness. So it would say, well, we think this is about 95% correct. And that's interesting technology, but it would even be even more interesting if you could have maybe 3 Watsons. So you could actually have a conversation with several Watsons. So I think that's a small example, but I think that's a very pertinent example of cognitive computing. The ability to actually have a computer that engages with us, that talks with us in our natural language that we speak, and recognizes the nuance of that language in a way that probably is domain specific. But that's one example. I know this term big data, those of you, if not all of you, with a strong technical background, you look at that term and it's got a lot of marketing, actually before I get there, a lot of marketing overtures to it. But when we talk about big data, we truly mean the fact that if you look at our world today, if you look at what type of data is growing at the fastest rate, we know that type of data is data from sensors. We know that it's data from social platforms, and we know what's growing the least, and also voice over IP is growing pretty fast as well. But we know what's growing the least is enterprise data, the data that is actually created out of the use of systems, of applications. But what does it say about a world where data is growing at this enormous rate? I think what it says is that the type of computer systems that we've used for the last 50 years may have reached the end of their normal life, and that our ability to solve future problems will be constrained if we continue with the same architectures, the same computer architectures that we've done in the past. And so that's sort of the reason why we think that there's a real reason for cognitive computing.